everyone. The topic I'm going to talk to you is called the quantum gravity. This is usually meant that the unification of the four forces of nature, and also mean the unification of quantum mechanics with general theory of relativity. I have done research on this topic for more than 20 years, since about 1999, and the chronology of the progress of my research is 1. The black hole theory of matter. Black hole theory matter. For this topic, I have an Eureka moment. Eureka means I get it, I understand it. In about 2006, after several years of research. And for the wave theory of matter, second stage of my research is the wave theory of matter. And for this, I had an Eureka moment much later, in about 2017 to 2018. I will begin my talk on the two theories, the theory of black hole theory of matter and the wave theory of matter, by first referring to a popular science book, which should be very familiar to you, and it's called the 101 Quantum Question by the retired director of the American Institute of Physics, and Mr. Kenneth Ford. And this one should be very familiar, a common book found in all public libraries, and it is by Mr. Ford. This book refers to 101 quantum questions, and all of majority of which Mr. Ford gave his own explanation, his own elaborations. But for the last chapter, the last chapter, chapter 15 of the book, he did not give any answers. He simply asked us to think about the question which is raised. And of course, there are two questions in this book in the last chapter, which I would give my own answers. And to this, in this question 94 and question 101, the last question in this book. And I will set out some equations in replying to these questions, and then this question lay the foundations underpinning theory to the black hole theory of matter and the wave theory of matter, which I just referred to. Now, firstly, question 94. For this question, Mr. Ford did not give any answer himself. He asked us to think about it. I will recite some of this part of this question to you, which is this is what I quote from the book. Why is 137.036 important? Because it's inverse. E squared divided by h bar c is equal to 1 over 137.036. It's a measure of the strength of the electromagnetic interaction, which is called a coupling constant. Why the numerical value of 137? Question mark. No one knows. It's a question physicists hope will be answered one day. One day is my own saying. One day in about 2017 to 2018, I suddenly realized, that's called a eureka moment, that the fine structure constant alpha is nothing more than a conversion factor. That is a conversion factor. Conversion factors such as the simple one, 1 kilogram is equal to 2.2 pounds, and or 1 meter is equal to 3.28 feet, or 1 inch equal to 2.54 centimeters. That's the conversion factor. So what is the conversion? What does this convert to? It converts Coulomb square, the electromagnetic unit of Coulomb square, or rather, to the kilograms in mass, and meter. It converted from Coulomb square to kilograms times meter times 10 to the power 7 times alpha. That alpha is the conversion factor, the fine structure constant. How do I derive this conversion factor? I derived it from just a simple conversion equation in all electromagnetic books, simple elementary ones, and year one, maybe year one in just high school certificate level book. That is, 1 coulomb is equal to 1 joule divided by 1 volt. I divided like 1 coulomb square. How do I get it? That's why I can get it here. So since maybe it's in reverse. 1 coulomb, maybe I just set it out. 1 volt is equal to 1 joule divided by 1 coulomb, so 1 joule divided by 1 volt, and 1 volt is equal to, is a unit of electric field, is equal to coulomb divided by 4 pi epsilon naught times a meter square. Meter, that is the length square, and in the numerator is also a unit of meter. And so when it is and 1 joule, what is in the numerator is equal to, by Einstein's famous equation, E equal to mc square, is 1 joule is equal to 1 kilogram, not 1 kilogram, not necessarily 1 kilogram times c square, that's the light speed square. And so what you got is in numerator kilogram meter square over second square, and what in the denominator you got coulomb, also a fraction, divided by 4 pi epsilon naught meter, because the meter square cancel with the meter in the numerator, so it's meter in the denominator of the denominator. And so what you got is finally and after you twist you transfer the coulomb in the numerator to the other side, to the Coulomb, or the left side, you got Coulomb square is equal to 10 to the power 7 times kilogram times meter. But that is not equality. That's not equality, because you still lack it, the conversion factor. That is, the conversion factor is just alpha. It's 1 over 137.036. That is the conversion factor. And after you add in, multiply also by the conversion factor, then the two signs become equal. So this is the first electrical moment I got by after I've worked out from my calculator for some time, and also I got some inspiration from the Cambridge Handbook of Physics Formula 2000 year edition, in which I found out that alpha is equal to mu naught. Mu naught is 4 pi times 10 to the power minus 7 E square. E is the elementary charge, 1.602 times 10 to the power minus 19 Coulomb square, times c, which is the speed of light, divided by 2h. H is the Planck's constant, which I will shortly talk about. From this, and from the equation which I just talked about, that's Coulomb is 1 Coulomb is 1 Joule divided by 1 volt. I got it finally worked out from my calculator. I worked out that is that alpha, the fine structure constant, is nothing more than just a conversion factor, which is not as mysterious as Mr. Ford said. Which only Mr. Ford is only quote from another scientist, which I think is John Mueller. Well, after I finish on the fine structure constant, next topic I'm going to talk is the H, the Planck's constant. H, you have the Planck constant is equal to 6.626 times 10 to the power minus 34 Joule second. The unit is Joule second, and the after dividing it by 2 pi, it becomes a reduced Planck's constant, which is 1.055 times 10 to the power minus 34 Joule second. Also, unit same is the same. It's the reduced Planck's constant. And the this belongs to the question 101. Answer 101, Mr. Kenneth Ford quote from Mr. John Mueller, the late scientist. The question, the simple question, how come the constant? This where did the constant come from? Where does the constant come from? How? And this constant, the answer to this question can take some time, not a long time, to come to answer. This came from Mr. Max Planck, from whom the name Planck's constant derived. In 1899, Max Planck discovered from this experimentally. This is not from any derivation mathematically. It's from experiments performed by himself or by other physicists of his time, that he got a equation, the equation which is now called the Planck's radiation formula, which now it is 8 pi h. The h is Planck's quantum, which is 6.626 times 10 to the power minus 34 joule second, divided by c to the power 3. C is the light speed, and multiplied by the frequency to the power 3, and divided by h bar. E is the natural logarithm base 2.781828, and to the power is a fraction, h bar, not h bar, is just h, times the frequency, which you denote it by nu, divided by k b. K is supposed one constant, 1.38 times 10 to the power minus 30 minus the power minus 23 joule per degree Kelvin, and times T. T is the temperature in degree Kelvin. Subtracting 1, minus 1. This is the 8 pi h divided by 3 c to the power 3 times nu to the power 3. Nu is the frequency, divided by divided by the denominator, e to the power. E is the natural logarithm base, h to the power. The logarithm is a power, h mu divided by kb times T. T is the temperature in degree Kelvin, minus 1. And from this equation, he's got all the other quantities in this equation are the pi, h, pi, c is the light speed. All these are known, and the variables are the frequency and the temperature. The only variables is the frequency and temperature, but it's got another constant appearing in this equation, which is h. In h, it appears twice in this equation. This is a new constant, new by the time in 1899. So it's got it, but it's so he's got this new constant, but it's Mr. Planck has no simple explanation for why he did this. He derived a number of quantities using this h bar, not using the h. H is equal to 6.626 times 10 to the power 34 joule second. He used h divided by 2 pi, to derive a new quantity called h bar, which is a reduced quantity, 1.055 times 10 to the power 34 joule second. And he used this quantity h bar and combine it with g, g, which is a Newton constant, Newton's gravitational constant. This constant was known before Mr. Max Planck's time. It was known in about 1795 by Lord Kelvin, the English scientist, Henry Cavendish, who used a device invented by the astronomer John Mitchell, also an English astronomer, from which he derived the Earth's mass, and from that experiment he also derived this gravitational constant of of Newton. Although Newton knew that it had to be a constant because the force of the gravitation is proportional to the mass of two objects divided by the distance square between the two objects, but he does not know what is the value of the constant, of the proportional constant. That proportional constant was only actually measured or derived by Lord Kelvin, Henry Davis, 1 century later, using a device called torsion balance, invented by the English astronomer John Michell, and its value was then known to be 6.673 times 10 to the power minus 11 Newton meter square per kilogram square. That is the value of the Newton gravitational constant. And c is the light speed, the speed of light. However, it was known for a very long time, even before Newton's time, in 1676, by the Dutch astronomer working in England, and using the effect, which is the time lag of the light which reaches Earth from Jupiter's satellites. In 1676, he used the time lag to calculate the light speed of the light, and it's known to be about 3 times 10 to the power 10 to the power 8 10 to the power 8 meters per second. 3 times 10 to the power 8 meters per second. And so that but these three, the values of these three constants is somewhat unexplained. Why Max Planck, after he got this new constant H in 1899, why he combined it with the Newton's constant, which was known a century before him, and combined it with the speed of light, which is known 2 centuries before him, into a set of Planck Length, Planck Mass, and Planck Time. This Planck, the Planck length is equal to 1.616 times 10 to the power minus 35 meters, and is equal to in numerical notation, it is square root of h bar times g, which is the Newton's constant, divided by c, which is light speed to the power 3 meter. And Planck mass is equal to 2.177 times 10 to the power minus 8 kilograms. Or in mathematical notation, this is square root of h bar times c divided by g kilogram. And Planck time is equal to 5.391 times 10 to the power minus 44 second. In mathematical notation, this is square root of h bar times g divided by c to the power 5 second. From this set of constant, this Mr. Max Planck, he did not fully explain why he invented this system of this set of Planck units. But I did read a book, it's just titled Max Planck, and he said if we wish to communicate we cannot communicate with any extraterrestrial beings with our own earthly quantity units, such as feet, such as meter, such as a kilogram, pounds. We cannot communicate this with the extraterrestrial being, but we can communicate it with Planck length, Planck mass, and Planck time, because it's composed of natural units derived from nature. Nature has provided units. G is naturally occurs in any equation of gravitational equations, and C naturally appears in any equation which involves the speed of light, and H bar naturally occur in any equation which involve the radiation and so on. And now we know that it's also the fundamental unit used in quantum mechanics. No quantum mechanics equation we can dispense with H bar. So we don't know whether Mr. Planck invented this set of units to communicate with extraterrestrial beings or not. But this is somehow his explanation of the significance of this set of units. We know also, if we divide Planck length by Planck time, we got C equal to C. That's the light speed. That is the time. You use the time required to travel at Planck length distance. That is the unit. That will be the C, the speed of light. Planck length divided by Planck times C. And what we also know that this is what I myself got it. Is the Planck length times the Planck mass times C is equal to H bar. H bar that's just the reduce the Planck constant. And this is also what I myself got it, because by working through the calculator with this Planck length, Planck mass, Planck units, I got it. G, the Newton's constant, is just equal to Planck length divided by Planck mass times c squared. No one else have ever mentioned this. I've read all the science books. No one has seemed to have to derive this equation from the G. G is the Newton constant is to Planck length divided by Planck mass times c squared. That is. The value is 6.673 times 10 to the power minus 11 Newton meter squared per kilogram square. And so we got to know how C is derived as Planck length by Planck time. We know the H bar is equal to Planck length times Planck mass times C. But how? Why? Why is to answer the question? This means simply to answer the question of John Wheeler, quoted by Mr. Kenneth Ford in his book. Why? How come the constant? The constant is, I can show you a synoptic diagram. I'm sorry that whenever it's repair here, it's in reverse. If there is a circular motion, something in circular motion with a mass of m, and then with the speed of c, that's light speed, then it has a axial vector which is called the angular momentum connected with it, which is perpendicular to the plane of the circular motion. And so m times c times m times c, and or if the radius of the circular motion is a Planck length, the mass is a Planck mass, and the speed is still c, then you will have a angular momentum connected with it, which is h bar. That's how the h bar comes from. For this, I don't think no one has ever got it, because in fact it is, if you refer to question 25 on page 56 of Mr. Caniford's book, and 56. I'm afraid I cannot show it because you may infringe Mr. Ford's copyright, but you can refer to yourself. Page 56, question 25, quantum question 25. In this book, in this question, actually, Mr. Ford has referred to the h bars as a unit of angular momentum, quantum angular momentum. Actually, it's actually, and if I can somewhat recite it to you. You cannot see it, so it's not infringement, it's copyright. Is that the orbital angular momentum of an electron in an atom can have only the value 0, h bar, 2h bar, 3h bar, 4h bar, and so on. And it means these are the natural units of orbital angular momentums. So I don't think no one has got this angular momentum. So the question is, how come the quantum, not what are the quantum of this h bar quantum? They know it is at least Mr. Caniford knows that it is angular momentum, units of angular momentums. Why there's such angular momentum? That is what's quoted in Mr. In the question 101 of John Mueller, by John Mueller. How come the momentum is where? What caused it? How did this come about? And this leads back to the black hole theory of matter, which I just mentioned. This is my own eureka moment. I first mentioned that I've studied this the quantum theory, my own quantum understanding of the quantum theory, quantum gravity theory, is composed of two parts. The first part is black hole theory of matter. The second part is the wave theory of matter. I first have to say the wave theory of matter is not invented by me. It is already 100 years old. It is invented by Louis de Broglie, a French physicist in the year 1922. So it's 100 years old. It's really matter. But somehow, after the immense innovation of quantum mechanics in 1925, and then and then later in the tide gradually turned, the wave theory of matter was gradually discarded in favor of a particle theory of matter, and finally it was completely superseded by a particle theory of matter in the 1960s. So actually, the wave theory of matter, I'm now only to somewhat want to reassert Mr. Louis de Broglie's theory of wave theory of matter. It's not invented by me. It is 100 years old. He posited it first, but then no one believed it. Not no one believed it, but some people has gradually modified it, and then they had tried to lessen the effect, the effectiveness of that theory, and then in favor of a particle theory, and gradually, finally, in 1960, it was completely superseded by the modern particle theory. But I'm now somewhat reasserted so as to explain and combine it with my own understanding of the quantum gravity. But then concerning the black hole theory is completely another matter. It is 100% my own innovation. I claim credit for this theory, the black hole theory of matter, and it is if it's proved in future, then I claim the credit of the first one who posited this black hole theory matter. And of course, I bear the same if it's finally proved to be false. I had this eureka moment in about 2005 and 2006 when I read about the various lifespans of the various particles. That is a period of time between the creation, the formation of a particle, and its decay and disappearance. That's the lifespan. I knew that there are only 3 particles which are stable, lifespan. And these are proton, neutron, and electron. Only 3. For all the other particles, the lifespans are millions of a second to billions of seconds. Although a neutron also decays in about 886 seconds after it's isolated from a molecule, or isolated from the helium atom, but it then turns into a proton. Then when a neutron is isolated from a molecule or the helium particle, then it decays into a proton, and the proton is of course stable. So neutron, proton, and electron are stable. And no other particles are stable. They only have very transient existence of billions of seconds. I'm quite the lifespan of a proton was said to be more than 10 to the power 29 years. But that's quite eternal by human standard. When we know that the age of the universe is often said to be only 10 to the power 10 years. I'm quite surprised that why the contemporary physicists do not consider this huge difference in lifespans among the particles to be something worthy of investigation. They only classify them as a stable particle, non-stable particles, stable particle free, and unstable, all the other particles are unstable. That is what they do. When I read also others about from other physics articles and books, and astronomy ones, those astronomical ones, books, I knew about the only other structure which has such long lifespan, more than 10 to the power 29 years, is black holes. Black holes. Black hole, this term, by this way, is invented by John Mueller in 1969. Formerly, the original idea of black hole came from the English astronomer John Mitchell, and who coined the name of dark stars. And in 1783, and then it was independently also posited by Pierre Laplace, the French physicist, in 1796. I think all of you have we know something about the black holes, but do not know whether you're aware. All of you are aware of the black hole conditions. The black hole condition is something by a simple equation: 2g times mass divided by distance is equal to c squared. That's 2gm divided by r to c squared, where c is the speed of light, and m is the mass of a object, a body, and r is the distance from the center of mass of the body. If an object whose mass multiplied by g, the Newton's constant, divided by the distance from the center of mass of that body, r, divided by that, and times 2 is equal to c squared, the light speed square. This is then called dark star by John Mitchell, the astronomer, or the French physicist Pierre Laplace. It's called dark star, or it's called a black hole by John Mueller and Stephen Hawking and Roger Penrose. Black holes. There's different names, but they refer to the same things. But the question is that we often say it is a star which undergoes the last stage of its evolution, and it is if a star is of 3 solar mass or over, more than 3 solar mass, and then when it undergoes the last stage of its evolution, it would collapse to a dark star or a black hole. It's just as main, it's the same thing. But I wonder, I was curious, can smaller masses also fit this equation. 2gm divided by r is equal to c squared. So I try to work out where can uranium atoms fit it. Uranium atom is a very high, a massive atom. It has 92 protons and 146 neutrons. So it's very massive. The gravity binding energy of this atom is very massive. So can it fit it? So I put the mass of the uranium atom in this equation. But 2gm, m is the mass of the uranium atom, divided by r, c squared. No, it does not fit. We can the mass of the oxygen atom or helium atom fit it? No, again no. Can the mass of the hydrogen atom fit it? No, again. But then I tried the Planck mass and the Planck length. The Planck length is the distance from the center of mass of the from the center mass of something, and the Planck length. I fit it in the Planck mass, the Planck length, put in this equation. It almost fit, almost fit. That's how it's remarkable. If it is gm divided by r equal to c squared, then it's fit. If we put the Planck mass into the equation, and the Planck length is in the denominator, multiplied by g, it is exactly equal to c squared. But I was puzzled by 2gm. It's usually said is the equation for such a equation for black mass equation is black hole equation is 2gm divided by r is c squared. So I wonder why. How come there's such a difference of 2? But this such remarkable so I say incident because 2gm divided by r just equal to c squared exactly fits if we substitute Planck mass, Planck length into this equation. So the 2 must not be just a coincidence. Just that there's an additional multiplier of 2. It should not be a remarkable coincidence. It must be some explanation for it. And then I read more books on mechanics, and then I finally understand another lyrical moment. It is because it is what we call the Hamiltonian. The Hamiltonian is the kinetic energy plus potential energy is equal to the net or resultant energy. The Hamiltonian. So if this comes from the original version of the Newton's gravitational equation, even the it comes from this, which is you have half m v squared, where v is the speed of the moving object moving in circular motion around the central mass, and then it is half mv squared is equal to the gm divided by r, and from which you get the v squared is equal to 2gm over r. That's the Hamiltonian, which is correct, of course. But it involves central mass and an additional mass moving in circular motion around the central mass. This is actually always correct. This is half v square is equal to gm over r. So v square is equal to 2 gm over r. That's how they get it, this equation. But it does not mean that gm divided by r is equal to the gm over r, of course, is not equal to half v square, which is not correct. gm is something else. That's why I got gm of r actually fitted if we substitute the mass of the Planck mass and the mass of the length of the Planck length into that equation. It means that in gm over r, m should be equal to Planck length, Planck mass, length should be Planck length. But because if we consider also a circular motion, a mass in circular motion around that central mass, that we got 2 gm over r this way. And so that actually gm over r c square is correct. 2 gm over r also is correct if it considers a second mass surrounding that in circular motion around them. That's what I got. This what we call Hamiltonian. The Hamiltonian arises because the kinetic energy and the potential energy are of negative sign. That is, so if the kinetic energy is half of the potential energy, which is always the same case, kinetic energy is always half of the potential energy, and they are of negative sign, so that the final net resulting energy is equal to half net of resulting energy is a half mv square. But it does not mean that the gm over r is equal to half mv square. Gm is something else, which is how I got it. It is the Planck mass. If it's Planck mass and the Planck length substituted in this equation, it is correct. It just fits. So it is explain the mystery of a 2 gm over r and gm over r. So what does it mean? It means there is something which is of Planck mass moving in the speed of light in a circular motion, and the radius of the circular motion is equal to Planck length. What does that mean? It means it's a black hole. A black hole of a Planck size, Planck mass, a Planck length and Planck mass, which thus create a angular momentum, which has an angular momentum connected with it, which is equal to h bar. We just explained h bar is equal to Planck mass times Planck length times c. So it means that it is just a black hole. Yeah. And h bar is ubiquitous. Whenever in all quantum mechanics equation, black mass is the fundamental unit. The h bar is the fundamental unit. So that means there must be such a Planck size, Planck mass and Planck length. That's a Planck size black hole everywhere, ubiquitous, everywhere. Others, how can all equations in radiation equations, all quantum mechanics equations has such a h bar? appearing in the whole equations connected with such experiments. That's how I got some. This is what I called it. I have an eloquent moment in 2006, where this Planck size equation, these Planck size black holes. I have tried even the smallest, the most fundamental element is element number 1, hydrogen atoms. But still, it does not fit this 2gm over r is equal to c squared. It does not fit. So where is it? But then I've thought and thought. It does not mean the fact that the proton does not fit. The proton, which is of a femtometer, that's 10 to the power minus 15 meters, it does not fit it. It does not mean that this proton, this Planck-sized black holes cannot be in existence at the center of the hydrogen atom. The center hydrogen atom is much smaller than can be much smaller than the femtometer, than the proton. So it does not mean when I calculate using the radius of the hydrogen atom, and I use it using the mass of the hydrogen atom, it does not fit. This does not mean that there cannot be such a Planck-sized black hole in the center of the hydrogen atom. It can still sit in hydrogen atom. We can take an analogy with the solar system. The solar system, the sun is in the center of the solar system, which is about, we now know this, about 1 light years in radius. About 1 light years. The outermost is the part is called the Oort cloud, and then within it we have the Kuiper belt, and within it you have the inner solar system, the 8 planets from the Mercury to the Neptune, and the sun sits in the very center of the 1 light year. If the proton is just of the outer surface of the proton is just the outer surface of that solar system. We can take an analogy that this Planck mass sits in the center of this system, of the solar system, in the same way as this is an analogy. So what we call the surface of the proton is just a surface, as a outer part of the outer to the Planck-sized black hole. Now I think I've stopped here. Okay. Because it's already 1 hour. Okay. Mhm.